Okay, so this is going to be our first day of the first unit of Algebra 2 for this year. And we're in the Probability and Statistics unit. Section 1.1 is applying the counting principle and permutations. So we already started the counting principle on Khan Academy earlier this week. And so what the counting principle really is that it's trying to calculate how many possibilities, how many possible combinations you have, depending on how many options there are. Combinations. Okay, so Sporting Goods Store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? So one way you can do this is a tree diagram. So here we've got our different choices for snowboards. Okay. So we have, and I'm just going to abbreviate these, so we have the all mountain, the freestyle, and the carving. For each one of those options, we can either pick soft or hybrid boots. We have soft or hybrid, soft or hybrid, soft or hybrid. So the total number of options are, we can have an all mountain board with soft boots, or we can have an all mountain board with hybrid boots. We can have a freestyle board with soft boots, or a freestyle board with hybrid boots, or we can have a carving board with soft boots, or a carving board with hybrid boots. So we have 6 total options for that. Okay, that's the basic counting principle. How many choices do you have depending on how many options there are? Try this one. Applebee's is running a special. You pick 3 meal deal. You have a choice of 1 or 3 appetizers, mozzarella sticks, chicken fingers, chips, and salsa. 4 entrees, pasta, chicken, beef, or chicken Caesar salad, and 2 desserts, ice cream, brownie, or apple crisp. Make a tree diagram to determine how many meal choices you have. I'd like you to go ahead and work on that, hit pause, and then come back and check my answer. So once you've done your tree diagram, you should have came up with all these different options. Okay, it's not necessary for you to write out all the options. Sometimes it is a good thing to see just so you can understand kind of where we're going with this process. So if you do that, you've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 different completely separate meals that could be put together if you're at Applebee's, given all of those combinations. So how could we arrive at a different way than drawing out these kind of lengthy tree diagrams? That's not a very feasible way if we're going to do this all the time. So let's think about what happened in the first 2 examples. So in the first 2 examples, I had 3 types of snowboards, and I had 2 types of boots. My ended up answer, to get 6 options, I multiplied all of my options together, and I got 6. Down below, at Applebee's, I had 3 options for main dishes, 3 options for appetizers, 4 options for entrees, and 2 options for dessert. If I multiply those together, I get 3 times 4, which is 12, times 2, which is 24. Okay, so it's much easier to multiply together the number of options that you have. That's the easiest way, quickest way. Okay, so the fundamental counting principle says if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. If you have 3 more events, 3 events can occur in m, n, and p ways, and the number of ways that all 3 can occur would be m times n times p. It's the simplest part of probability. You're just multiplying all your possibilities together. Okay. So at a used book sale, you are interested in 5 novels, 3 nonfiction books, and 7 comic books. In order to figure out how many choices you have, you would simply multiply those together, and that would give you 105 options if you're choosing one of each kind. Okay? So, example 3, the digits 0, 1, 2, 3, and 4 are used to generate 4-digit customer codes. How many different codes are possible if the digits can be repeated? So here's our 4 slots. And we can choose any of those numbers for these 4 slots. So we have how many options? We have 1, 2, 3, 4, 5 options. And because they can be repeated, I have 5 options for every slot. So I just have 5 to the 4th power, or 25 times 25, which is 625 options. But what if they can't be repeated? So in that first slot, I have 5 options. I've got 0, 1, 2, 3, 4. So I have 5 options here. But now say I choose a 4. Now I can't choose that again. So now I only have 4 options left. Then I choose the 0, so those 2 are out. Now I only have 3 options left. Now I've chosen the 1. Now I only have 2 numbers left to choose from. So there would be a difference. That's a 6 and that's 20. So now we only have 120 options. So just by stipulating that a number cannot be repeated, we seriously decreased our number of options from 625 down to 120. So I took 505 options off the table just by decreasing by 1. Just by not being able to repeat one of those digits. So an ordering of permutation of n objects is a permutation. So permutation order matters. Okay. There are 6 permutations of the letters A, B, and C. So you've got A, B, C, A, C, B, all of these. How can we arrive at the number 6 without having to generate a list of the possible orders? So one of those ways is you're going to see a symbol, looks like an exclamation point, and it's read as n factorial. And it's equivalent to whatever that number is multiplied by itself and all the subsequent numbers down to 1. So if you have 5 factorial, that equals 5 times 4 times 3 times 2 times 1. Those are all of our options. So 5 times 4 is 20, times 6 would be 120. This will not usually be a negative number. It's possible that it could be, but it's usually positive numbers. If you had 10 factorial, you would have 10 times 9 times 8 times 7, 6 times 5 times 4 times 3 times 2 times 1. And you can do that on your calculator. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that gives you 3,628,800. Now, you don't want to keep doing 10 times 9. So on all of your calculators, you should have a factorial key. If you have one of these more complicated calculators, you're going to need to get into the catalog for that and know the code for that. If you have a more simple calculator, which I actually prefer that you have, you do not need a graphing calculator for this class, you should have a factorial key. So on this calculator, it's right here. And in order to use that, what you would need to do 10. Anything that's in yellow is going to require you to push the shift key first. You're going to shift and then factorial and equals. And there's our answer of 3,628,800. Okay? We'll do more practice on that in class, so if you're not quite understanding what that's about, we'll be doing that on Monday in class. Monday and Tuesday. Okay? All right, so Charlie Gibson has 8 news stories to present on ABC World News. How many different ways can the story be presented? So if you think about that, you've got 8 options, 8 slots that they have to put these stories in order, which they actually do, by the way. They say, okay, this story's going to go first, we're going to end with this story, and then they kind of figure out the stories in between. So here you have 8 choices. Once that first story, the headline has been set, every time you have a story, you've got one less to choose from. The easier way to write that would be 8 factorial. And if I'm doing that on my calculator, which would be the smart thing to do, you would have 40,320 options of ways that they could order those stories on the news. Okay? All right. If the news had to be shortened because the football game ran into overtime and only 3 of the stories could be presented, how many possible ways can a lead story, a second story, and a closing story be presented? So now we only have to deal with 3 of those options. So I still have 8 choices for the beginning. Now I only have 7 to choose from for my second story. And now for my last story, I only have 6 to choose from. So now we've decreased by quite a lot because now we're only placing 3 stories into the mix. So now you're not going to use your factorial key. Now you're just going to do 8 times 7 times 6, which will give you 336 options of how you could line those stories up. Okay? So when we have something like this, we have 8 options, but we're only choosing 3. Okay? Because you're not going to pick every option every time. So we call that a permutation of 8 objects taken 3 at a time. And the way that we write that is subscript 8, these are our total number of choices, a big P for permutation, and 3 for the number of choices, that number that we're choosing. Okay? So when you are calculating that, you're going to use this, so P, N, R. You also might see it P, N, R, like that in parentheses. You'll see that 2 different ways. The formula is exactly the same. So you take your total number that you have to choose from and the difference between the number you have to choose from and how many you're choosing, and you find that factorial. So if you notice the difference between laying out all 8 stories and laying out only the first 3, comparing the 2, which are the 5 numbers we didn't care about on the second situation. On the second one, we didn't care about from 5 down. Okay? Those are going to cancel out. So let's do one of these and we'll see what happens. So how many different ways can 4 raffle tickets be selected from 50 tickets if each ticket wins a different prize? So in that case, order matters because the first ticket drawn is going to win a specific prize. The second ticket drawn is going to win a specific prize. So order does matter there. So we're going to write that as P50, 4. You can also write it P50, choose 4. Okay, and so either one of these ways to write that would be fine. But when we do the formula, it's always going to be the same. The number that you have to choose from, which is 50, factorial, and then here you're going to subtract, the difference between how many you have to choose from and how many you're choosing. So 50 minus 4, factorial. So when we simplify that out, that would be 50 times 49 times 48, correct, all the way down to 1. Obviously not going to write all those out. Okay, so 50 minus 4 would be 46, factorial, which would be 46, 45, 44, all the way down to 1. So what essentially happens is that everything from the number you're not choosing down can cancel out, just like here. In our second situation, we were only choosing the first 3 spots, so we had 8 choosing 3. We weren't choosing the last 5. We don't care about those, so they're going to go away. So now when you're calculating this number, you are just going to do 50 times 49 times 48 times 47, and you get 5,527,200. So your chance would be 1 in 5 million, okay? Actually, your chances of winning all of those. So when you're doing that in your calculator, you can do 50 factorial, get that answer, divided by, you can do 50 minus 4 in your head, and then do parentheses 46 factorial, close your parentheses, and equals, and you'll get the same answer. We'll talk in class about parentheses and closing your parentheses on your calculator because it is an important step that if you don't do, it changes the expression that you're trying to evaluate. Okay? So, you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. In how many orders can you complete your 4 assignments? So, try and do that one on your own and then come back and check your work. Okay, so you should have done, order matters because once you finish one assignment, you don't have to do that again. So you have 6 to choose from, and and you're choosing 4. So I'm going to write that as 6 factorial over 6 minus 4 factorial, which would give you 2 factorial. To me, it's almost easier to do this. So 6, 5, 4, 3, 2, 1 over 2, 1. These are all being multiplied together, always. So the 2 times 1 and the 2 times 1 can cancel out from both. So you have 30 times 12 will give you 360 different arrangements that you could put those 4 homework assignments into. Moving on. So permutations with repetition. So what if you have something where one of those items that you're trying to put in order repeats itself? So consider the letters SOS. You'll notice this one is in boldface to kind of tell it apart from the last S. If you consider bold S and regular S to be distinct, then there's 6 permutations, and here they are. Okay? But if the 2 occurrences of S are considered to be interchangeable, then there are only how many permutations? Well, let's see. So we would have SOS. Look how many of these are the same. So that matches up with that. The OSS and the OSS are the same, and the SSO and the SSO are the same. So there's really only 3 different permutations of that. They each just happen to show twice, if we consider that S and an S are the same and one is not bold from the other. Okay? So, how could we arrive at that answer without having to generate all of the permutations? Okay, so to figure that out without all the permutations, you have to take into consideration the number of things that are being repeated. So in this case, how many, in SOS, what's the number of letters of items that repeat? And how often? And how many times? Because we need to divide that back out, otherwise we're counting it twice. Okay? So you're going to do n factorial, but now you've got to divide, and really you're choosing all 5 items. But the other thing you have to divide by is the number of items, so say an S1, and how many times it repeats. So let's clean that up a little bit. So let's use this example up here. We have 3, choose 3. So I've got 3 factorial for our SOS. I have 3 factorial, and I'm choosing 3 factorial, but one of my letters, the S, repeats twice. So I need to divide that by 2 factorial, which will give me 3 times 2 times 1 over 2 times 1. Everything cancels out by the 3, and that is in fact how many options that we had. Okay? So let's try these down here. I'm going to do soccer, and I'll have you, soccer and swimming, and then you'll do tomorrow. Okay, so soccer, we have 6 options, right? 6 letters that we're choosing from, but one of those letters repeats twice. So you have to divide it by the number of times something repeats, for everything that repeats. Okay, so now we've got one of those that repeats twice. So you'd have 6, 5, 4, 3, 2, 1, divided by 2, 1. You should know when I'm doing factorial, if I write it out, I usually don't bother putting the dots in between. I just need you to understand that they're there. So the 2 and the 1 divide out. I have 30 times 12, which would give me 360. Okay, so let's try swimming. So in the word swimming, we have 2 M's and 2 N's. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters to choose from, but the M repeats twice and the I repeats twice. So we need to cancel out those options, otherwise we're counting them twice, which we cannot do. So this would be 8, 7, 6, 5, 4, 3, 2, 1, all over 2, 1, and 2, 1. So let's do this an easier way. 2 times 1 times 2 times 1 is 4. Let's cancel that out. And when you multiply the rest of that together, you go to 8 times 7 is 56, times 30 times 6 would give us 10,080 different ways that we could put those letters in order. Okay, go ahead and try the word tomorrow, and then come back and check your work.
Hi, Miss D.
So we have 1, 2, 3, 4, 5, 6, 7, 8 letters to choose from. The O repeats 3 times, so we're going to need to take out a 3 factorial. And the R repeats twice, so we're going to need to take that out as well. And so we have 8, 7, 6, 5, 4, 3, 2, 1, divided by 3, 2, 1, 2, 1. So 3 times 2 times 1 is 6. That cancels out. The 2 and the 1 and the 2 and the 1 cancel out. So you have 8 times 7, which is 56. 5 times 4 times 3 is 60. And so 56 times 60 would be 3,360. Okay, so that was actually the section of 1-1. If you want to take a break, finish your notes later, that's cool. Otherwise, let's keep rolling. So, sometimes it's not important to know the order of something when we're counting the number of options that we have. So, and how they can be arranged. So, like in permutations, it does matter. Whoever comes in first, second, third, once somebody's in first place, nobody else can be in first place. Okay, that's just the way that it is. If you're just gathering, say, a group of people on a committee, it doesn't really matter who you chose first or who you chose last. They're just on this committee, and order makes no difference at all. Okay? So, a combination is a selection of R objects from a group of N where the order is not important. So that's the biggest thing to remember. Okay? Combination, you're just combining things into one group, but it doesn't matter what order they're in. So the combination of objects taken at a time, it's going to look a lot like permutations, same way. Again, it can also be, sometimes you'll see it written like this, will be, and it starts the same as our permutation formula, so it's n minus r factorial times r factorial. Okay? So that's the difference in the formulas. So an example would be, cards is a very common example. So standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. If the order in which the cards are dealt is not important, how many different 5-card hands are possible? So order does not matter. So you have 52 to choose from, and you're choosing 5. So in that case, you would have 52 factorial over 47, because our number possible minus the number we're choosing would be 47 factorial and 5 factorial. Now, you can absolutely put this in the calculator. You might want to do it both ways so that you can check yourself. This is where you need to be careful how you're entering things in the calculator. So, shift factorial, get that answer. Divided by, do a parentheses, because this is one amount, and you need to make sure that you're calculating that correctly. 47 factorial times 5 factorial, close the parentheses, that will give you an actual amount for that denominator, and then divide out. And you should get 2,598,960. Different options. Now you see why Vegas is always ahead when you guys are thinking about gambling in the future. That's why they make money and you don't. Okay? The odds are always in the house's favor. If you're going to do this the long way, which it's not really that hard to do. So 52, 51, 50, 49, 48. Everything from 47 on down to 1. On the top and the bottom are going to cancel. So you don't need to have that part down. Then you just have 5, 4, 3, 2, and 1. Well, 5 times 2 is 10, and that goes into 55 times. 4 times 3 is 12, and that goes in there 4 times. So really now you're just multiplying 52 times 51 times 5 times 49 times 4. And you should get the same answer, and we do. 2,598,960. Okay? So if you're unsure about how to use the calculator for your factorials, or it's too much of a hassle, this is another way you can do it. Also makes you practice your fractions. Okay, so at how many 5-card hands are all 5 cards of the same color? So we only have 2 options in a deck of cards. We have black cards or red cards. And in each group of those, we have 26 cards. So now you have 26 choices, and you're choosing 5. So you have 26 factorial over 21 factorial and 5 factorial. So this is a reminder that your denominator total should equal your numerator when you're dealing with combinations. Okay? So 21 plus 5 is 26, 47 plus 5 is 52. As long as you're checking that, you should be good. So 26, 25, 24, 23, 22, everything from 21 down is going to cancel. 5, 4, 3, 2, 1. Okay. So 4 times 3 times 2 is 24. That's 12 times 2 is 24. So that cancels right out. The 5 and the 25 simplify. So now you just have 26 times 5 times 23 times 22, and you should get 65,780. And if we do it on the calculator, we would have 26 factorial divided by, if you do not do this with the parentheses downstairs, it will not come out correctly, because essentially you'd be multiplying by 5 factorial instead of dividing by it. And you get the same answer. Okay? So, parents have 10 books that they can read to their children this week. 5 of the books are nonfiction and 5 are fiction. If the order in which they read the books is not important, how many different sets of 4 books can they choose? So that means they would have 10 to choose from, and they're choosing 4. So you would have 10 factorial over 6 factorial, 4 factorial. So you would have 10, 9, 8, 7, 6 through 1 will cancel, 4, 3, 2, 1. So the 4 and the 2 cancel with the 8. 3 goes into 9 3 times. You have 10 times 21, which will give you 210 options. Okay? In how many groups of 4 books are all the books either fiction or nonfiction? So now we only have 5 of each to choose from, but we're still choosing 4. So I want you to think about for a second, is it a higher likelihood that you are going to choose 4 of the same or less? There are less options or more options? Okay, I just want you to think about that before we actually calculate it. So we'd have 5 factorial over 1 factorial, 4 factorial. That would be 5, 4, 3, 2, 1. 4 down to 1 is going to cancel. So now you only have 5 options. If you're trying to only pick one type of book, then you've really cut down the number of times that that's going to happen. Okay, the probability of that is a lot less. Okay? Okay, so multiple events. This is where and or is a big, you want to really pay attention to those terms. So in finding a number of ways both an event A and B can occur, you need to multiply. When you find the number of ways an event A or B can occur, you need to add. So let's just think about that for a minute. What are the chances that you're going to win a raffle and win a vacation? Think about if that's going to be a higher probability or smaller probability than if you win a raffle or a vacation. There's probably a larger probability of doing one or the other. To do both, now you've doubled up on how much you need to do. So think about that as we're working through these. So a student council consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. How many different committees of exactly 2 seniors and 2 juniors be chosen? So we're dealing with, now you have to pick 2 seniors and 2 juniors. It would be much easier to pick 2 seniors or 2 juniors, because then it doesn't matter. what the other ones are. If we only need 2 seniors, the other 2 could be freshmen, they could be sophomores, they could be a combination of a junior and a sophomore. But as soon as you put that "and" in there, now you're making that situation more complicated, which means it's less likely to happen. So first we're going to deal with our seniors. We have 6 seniors to choose from. Doesn't matter what order we choose them in, and we're choosing 2. Because it is an "and" event, is making that more complex, we're going to multiply those possibilities together. There are 5 juniors to choose from, and we're choosing 2. So you're going to do the same process that you had before. So you'd have 6 factorial over 4 factorial, 2 factorial, multiplied by 5 factorial, 3 factorial, 2 factorial. You can certainly put all this in the calculator. I would challenge you to really think about what is actually easier. The calculator is not always actually easier, okay? So let's just do this first one. So you'd have 6 times 5. Everything from 4 down would cancel. So then you would just have 2 times 1. When you're multiplying fractions together, you can essentially turn that into one fraction because you have all of your numerators multiplied together by all of your denominators. So then on the top for this one, you would have 5 times 4. Everything from 3 down would cancel, times 2 times 1. That's actually pretty easy to simplify because 2 times 2 is 4, so that just goes away. That would give us 30 times 5. So we have 150 different ways that we could choose 2 seniors and 2 juniors. Okay? How many different committees of at most 4 students can be chosen? Okay? So you have a possibility of choosing, what do you have here? You can choose 4, 3, 2, or 1. You can have a committee with 1 person, right? Of at most 4, which means it could be less than 4. So we need to total up how many we have. We have 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. That gives us 18 total. Okay? So think about if this is going to be an "and" or an "or." I can pick 4 people for a committee, or 3 people, or 2 people, or 1 person. So these possibilities we're going to add together. Okay? So we have a total of 18 students, and we can choose 4. Plus, we can choose 18. Plus, we can choose 2. Plus, we can choose 1. Can't choose 0, there's no committee there then. Okay, so if we were to simplify that, we would have 18 over 14 and 4 plus 18 factorial over 15 and 3 plus 18 factorial over 16 and 2 and 18 factorial over 17 and 1. Okay? So let's simplify that down. Upstairs here we would have 18, 17, 16, 15 over, because 14 and down would go away, 4, 3, 2, 1. So 4 would go into 16 4 times, 3 goes into 18 6 times, 2 goes into 4 twice. So we would have 6 times 17 times 2 times 15, which is 3,060. Okay. Plus, we're going to do the same thing for the 18. I'm going to move this over here. So we have 3,060 options of how we could choose 4. Here you would have 18, 17, 16. Everything from 15 down is going to cancel. 3, 2, and 1. 3 times 2 is 6. That goes into 18 3 times. So you have 17 times 16 times 3. So that's 816 possibilities. 18 times 17. Everything from 16 down is going to cancel. And you just have 2 and 1. 2 goes into 18 9 times. 9 times 17 is 153. And then here, everything from 17 down would cancel out, so you just have 18. So the number of different committees that at most 4 students could be would be a sum of these 4 numbers. So you have 3,060, 816, 153, and 18. So that gives us a total number of 4,047. Okay. So I'd like you to try the next 2 problems down below and then come back and check your work. So for our first option, you want exactly 2 comedies and 3 family movies. If it helps you to circle the word and or to help you remember, that would be an important thing for you to do. So out of the comedies, you have 12 to choose from, you're choosing 2. Family movies, you have 9, you're choosing 3. There's the work for that problem, and you should have come up with total number of movie combinations to be 5,544. Okay, so now you can afford at most 2 movies. So your choice is you can rent 2 or you can rent 1. Because you don't have to rent 2 movies, that's an option, but you could go ahead and just rent 1 movie and save your other money for popcorn or something. Okay, so if we do that, we have 41 total movies to choose from. We're choosing 2. Or our other option, we're going to add the possibility of having 41 movies and choosing 1. So once you do that, that's 20. So that is 820 options plus 41 options, so you should get 861. Okay, good. Okay, subtracting possibilities. I'm actually going to skip this one until we're doing it in class. Yeah, we're going to skip this one until class. I'd like to kind of get on to Pascal's triangle. Okay, so many of the relationships that you see in combinations actually lead up to something called Pascal's triangle. This can be used for a variety of things. It can be used really easily to figure out larger binomials that you're multiplying and figure out what coefficient is going to go in the front of it. It also is based off of probabilities. Okay, so in row, say for example in the 3rd row, we have 3 to choose from. Our options, we could choose 0, 1, 2, or 3. In the 5th row, we have 5 options, picking none, picking 1, 2, 3, 4, or all 5. Okay? Pascal's triangle also can be written in a numerical form, and the way that we get that, if there's 0 options and you're going to choose 0, there's only one way to do that. Okay? In the 1st row, and we start with row 0, I want you to notice that. Okay, in the 1st row, if you have 1 option to choose from and you're not going to choose any, there's one way to do that. If you're going to choose 1, there's one way to do that. In the 2nd row, okay, the way Pascal's triangle works is the 1s go all the way down the side, like this continually, and they actually end up being a sum of the 2. So you have 1 plus 1 is 2, that goes in the middle. 1 plus 2 is 3, 2 plus 1 is 3. These are going to become our coefficients for binomials, which is coming in a moment. Okay, 1 plus 3 is 4, 3 plus 3 is 9. Okay, so I have 1's down the side. Sorry, I had to go back. I had a mathematical error in mine that I needed to go back and fix, so sorry about that. And so 1 plus 3 is 4, 3 plus 3 is 6. This is where my error was. I had a 9 originally because I wasn't paying attention. And then I realized when I got to the end that things were not working out the way they should have. 1 plus 4 is 5, 4 plus 6 is 10, 10 and 5 and 1. 1 plus 5 is 6, 5 plus 10 is 15, 10 and 10 is 20, 15 and 6. And we're going to go ahead and do the 7th row. 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so according to, for number 6, according to this, if I'm in my 7th row, if I have 7 baseball caps to choose from and I want to trade 3, in my 7th row here, here's the option of not choosing any. choosing 1, choosing 2, choosing 3. So according to Pascal's triangle, there should be 35 possible combinations that I could choose from, okay? So if I'm going to calculate that, I'm going to use 7, choose 3, which gives me 7 factorial over 4 factorial, 3 factorial. If I write all of those out, I have 7, 6, 5, 4, 3, 2, 1 over 4, 3, 2, 1, 3, 2, 1. I didn't need to write out this 4, 3, 2, 1. Those will go ahead and cancel. Then when I'm simplifying this, 3 times 2 is 6. That cancels out. All I have left is 7 times 5, which does give me 35. So I'm just doing this to verify with you that what the Pascal's triangle is telling us. If we're in the 7th row and we have 3 things to choose from, we have 35 different options of how we could do that. Okay? So try this one on the top of the next page. Out of 5 finalists, your class must choose 3 class representatives. So use Pascal's triangle to find the number of combinations of 3 students that can be chosen. So if you're going to use Pascal's triangle, now the guesswork is out of it. So if you're in the 5th row and we're choosing 3, this is choosing 0, 1, 2, 3, there should be 10 options for that. 10 combinations. I'm going to quickly do the mathematical part just to verify. So we have 5, 4, 3, 2, 1 over 2, 1 and 3, 2, 1. Those cancel out. That goes in there. 5 times 2 is 10. So that checks out. Okay. Now I'm going to show you how they work with binomial expansions, because when we start getting into binomials, this makes all of it so much easier. So, and that is when you're taking the same binomial and taking it to the 2nd power, 3rd power, 4th power. It's how you can determine what those coefficients are going to be. So anything to the 0 power is going to be 1. Anything to the 1st power is just going to be that number itself. Now we can start using in the 2nd row, we're taking it to the 2nd degree. So our coefficients for that row are going to be 1, 2, and 1. So we'll have, in descending order, x squared, 1x squared, plus 2x, plus 1. Those are the coefficients that we see in the 2nd row off the Pascal's triangle. Those are the coefficients that correlate right here. Okay, if we want to multiply that out to, oh sorry, should be a y. Okay, if we multiply x plus y times x plus y, we do get y squared, xy, xy, and x squared, which is exactly what we have here. We have 1x squared, 2 of the xy, and 1 of the y squared. Okay, and we have that there. Let's go ahead and use the 3rd row. So in our 3rd row, our coefficients should be 1, 3, 3, and 1. The other thing I want you to recognize is that when we're using Pascal's triangle, your coefficients are always going to be there. And what happens is your exponents here, the total of them always need to total to your number of degrees here. So x to the 1st, x is the same thing as x to the 1st, y is y to the 1st. Your x values are going to decrease as your y values are increasing. When we have no y there, that's actually y to the 0 power because that totals 1. Here we actually have x to the 0 power because that still totals 1. Your exponent should always total the degree that you're working with. So in our 3rd row degree, our exponent should always total 3. xy, 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 and xy. With our x's, we're going to start 3, 2, 1, and 0. Y's are going to do exactly the opposite. They have to total 3, so they're going to have to increase by 1. 0, 1, 2, and 3. Double check that that all works. You have your exponents total 0, or excuse me, total 3, total 3, total 3, total 3. So we're good to go. These are all addition. That can change depending on what that number is. And so to simplify that, you would have x cubed plus 3x squared y plus 3x y squared plus y cubed. That's your answer, and you're done. So instead of having to multiply out x plus y times x plus y, get that answer and multiply it again, this is your shortcut to get there. If we're in the fourth row, here's our fourth row in our Pascal's triangle. Our coefficients should be 1, 4, 6, 4, and 1. Okay, so we have 1, 4, 6, 4, and 1. Our two terms are x and y, x and y, x and y, x and y. And now it's just a case of numbering our degrees on the way down. All of our x's are going to start. Your first term is going to be the highest and is going to be decreasing. Your second term, in this case the y, is going to start at 0 and increase. So you should have 4, 0, 3, 1, 2, 2, 1, 3, and 0, 4. So if we simplify that, we should have x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. So using Pascal's triangle, it can only be used when you're taking a certain term binomial to a power, but this is obviously a much simpler way to get those coefficients in the front and be able to simplify that expression than having to multiply anything out. Okay? And there is a definition for binomial theorem. I think the definition and the formula is not as user-friendly as we'd like it to be. So I'm going to give you that in class along with the Pascal's triangle, and you can just tape it into your notes. I'd rather you be able to actually apply it. So let's go ahead and move on to chat number 7 and put a star by that to remind ourselves that we need to do that in class. So x plus y to the 6th. So I'm going to go ahead and look at my 6th row on my Pascal's triangle, so that my coefficients are 1, 6, 15, 20, 15, 6, and 1. So 1, 6, 15, 20, 15, 6, and 1. Put in all of your terms, and then we'll just go ahead and add the exponents. Okay, so your x's, since that's the first term, should start at 6 and decrease all the way down to 0. Y should do the exact opposite. That should start at 0 and increase all the way to 6. So 6, 5, 4, 3, 2, 1, 0. And then 0, 1, 2, 3, 4, 5, 6. Okay? Okay, so this last page, we're just going to do 3 examples. We'll be doing more of this in class. If this is really not clicking in with you quite yet, it will. In fact, I think I may leave example 9, 10, and 9 and 10 to do in class. We can do those as in close notes together. Because once you throw coefficients in there, it is going to get a little bit more confusing, if you're not confused already. So let's go ahead and do that. So our first term, let's just define what our terms are. So our first term is 3x, right there. Our last term, our second term, is negative 2. Okay, then we're looking in the 4th row of the triangle. So in the 4th row, we're going to have 1, 4, 6, 4, and 1. So we know that those are our 4, and I'm spreading it out a little bit, and you're going to see why in just a second. So since our first term is 3x, and our last term is negative 2, that's what's going to be in behind every coefficient. Those are our terms now. Instead of the xy, we have 3x and negative 2 repeating every time. Now we've got to add in our add in our powers. So we're going to start with our first term, which is a 3x, 4, 3, 2, 1, and 0. And with our second term, do the exact opposite, start at 0 and increase all the way to 4. So in order to simplify this, this is just a mess to look at, so we really need to clean that up. Anything to the 0 power is going to just be a 1, so we can eliminate that. Now this is where you need to be careful. This is 3x to the 4th, which is not the same as 3x to the 4th. They are not the same thing. You must raise each of those powers, each of those bases to the power of 4. So that would actually give you 81x to the 4th. Okay? Then you've got 4 times this. So again, 3 to the 3rd is 27, x to the 3rd. And we're going to multiply all that by negative 2. So now if we simplify that, 4 times negative 2 is negative 8. And then we actually have to multiply that by 27. So let's take some calculator help. We can do that. And so 4 times 27 times negative 2 would be negative 2/16. So negative 2/16 x to the 3rd. So each one of these you're going to have to simplify first before you can get down to your final answer down here. So 3x, the quantity 3x squared is actually 9x squared, and then negative 2 squared would be 4. So now we've got to multiply positive 4. So now we've got 6 times 9 times 4, which gives us 2/16 also. Just happens to be. Plus, now we've got 4 times 3x, and then negative 2 to the 3rd is negative 8. So now we've got to multiply all those coefficients together. 4 times 3 times negative 8 would be negative 96. So let's take the addition out of there. So we've got negative 96. And that'll just be our x term. And then finally down here at the end, now we've got no x's anymore to deal with, because 3x to the 0 power is just 1. 1 times 1 is 1. Negative 2 to the 4th is 16. So that is our final answer. When you're using binomial theorem, your degrees should be decreasing from largest down to smallest, and 9 times out of 10, all of them should be represented. Okay? So we will do example 9 and 10 in class. I think you've listened to me long enough, and there's a lot to take in. So we will be doing this on Monday, Tuesday. The rest of the unit will be up by the weekend, and good job.